Hey, welcome back to Rithmetic with Ron. When we multiply fractions, typically we will reduce the fractions at the end. But today I'm going to show you how you can do some of that reducing early by canceling diagonally. Go ahead and hit subscribe and enjoy the video. Let's begin today's lesson with a very quick review on multiplying fractions. If I multiply 4 over 8 times 3 over 6, I multiply straight across the top. 4 times 3 is 12. And I multiply straight across the bottom. 8 times 6 is 48. Okay? If you would like a more in-depth review or explanation of multiplying fractions, go ahead and click this link and see a video on how to do that. Now I'm going to take 12 over 48, and what I need to do is simplify it, and I'm going to do that by dividing the top and bottom by the greatest common factor between those numbers, and that's going to give me 12 divided by 12 is 1, 48 divided by 12 is 4, and my final answer is 1/4. If you want to see a more in-depth explanation of reducing fractions, go ahead and click this link. Now, let's take a look at this problem and realize that had I done the simplification first, I would have had an easier problem. 4/8 could be simplified by dividing 4 out of the numerator and denominator. If I divide the top and bottom by 4, I get 4 divided by 4 is 1, and 8 divided by 4 is 2. Well, let's do the same thing with the second fraction, 3 over 6, and I can evenly divide 3 into the numerator and the denominator, and I get another 1/2. Using our rules of multiplying fractions, we get 1 times 1 is 1, and 2 times 2 is 4, and look, I get the same answer whether I multiplied first and then reduced, or if I reduce first and then multiply, doesn't matter. I get the same answer, okay? Now let's take a look at a problem that's maybe a little bit more difficult because we're not going to be able to reduce the fractions the way we did in this problem, okay? Let's take a look at 7 over 12, and we're going to multiply that by 4 over 35, okay? Now, if we take a look at these two fractions, you can see that there's no common factor between 4 and 35, and there's no common factor between 7 and 12, okay? If I multiply this out, I'm going to get 7 times 4 is 28, and 12 times 35, might have to use a calculator or do it old school by hand, but you're going to get 420. Then, if we were going to reduce this, we would need to either find the greatest common factor right away or keep dividing by smaller factors, and that's going to take some time, right? We're going to spend a little bit of time working on that. What if we could take the simplification step and move it to the beginning? Well, we tried that with the last problem, and it worked because the numerators and denominators had similar factors, but we don't in this problem. So what are we going to do? What we are going to do is learn a new step about canceling diagonally. So what I'm going to do is show you how that works, and then I'm going to explain why. Let's look at these diagonals, 7 and 35. And I want you to see that 7 is in the numerator and 35 is in the denominator. Even though they're in different fractions, what I can do is put them together in their place. 7 is in the numerator, 35 is in the denominator, and now I can reduce by dividing 7 out of the numerator and denominator and get 1 over 5. Okay, so I'm going to do that in this problem, and I'm going to cancel 35. I'm going to divide by 7. 35 divided by 7 is 5, and 7 divided by 7 is 1. Hang with me, because we're going to finish the problem and see the answer, and then I will explain why it actually works, okay? Let's go ahead and do the same thing with the other diagonal. 4 is in the numerator, and 12 is in the denominator, and I can divide those by taking 4 out of the numerator and the denominator and simplifying to 1/3. Okay, so 12 divided by 4 is 3, and 4 divided by 4 is 1. What this gives us is a new set of fractions. Instead of 7 over 12, I now have 1 divided by 3. And instead of 4 divided by 35, I now have 1 divided by 5. So I'm going to rewrite this. And now when I multiply straight across, I get something much simpler, 1 over 15. Okay? Now you might say, how do I really know that that's the final answer? Well, if we were to go back and redo the part where we multiply this with big numbers, we would get 7 times 4 over 12 times 35. This is just taking the original fractions and multiplying straight across the top and bottom. And we said that we would have 28 over 420. Now look at this number and look at this number. If we can divide and reduce this fraction down to this fraction, first of all, that means that you should be able to type this in a calculator and get a decimal, and type this into a calculator and get the same decimal. That tells you that they are equivalent fractions. But the other thing you can look at is the numerator and see that a numerator of 1 is 28 times smaller. Does that mean that I could divide 28 out of the top and bottom? It does. Go ahead and try this for yourself, and you'll see that if you take this fraction and you divide by 28 out of the numerator and denominator, you will actually get 1 over 15. So what we did there was we canceled numbers, we reduced the fractions diagonally and multiplied, and we took the reducing step, the fraction reduction, reducing the fraction. We took that, and instead of doing it at the end, we did it early on. And we did that by looking at the diagonals, and we rewrote them. We took the diagonals and we rewrote them as a fraction and did the reducing step ahead of time. Okay? Now, I'm going to erase this, and we're going to talk about why does this work. This is not just some silly made-up step. There's actually a reason why this works. Okay? What we're going to talk about is something called the commutative property of multiplication. The commutative property of multiplication. Well, what is that? It's a property that says if you multiply two numbers, two factors, you multiply them together, you get a product. You can switch the order and you get the same answer. How about one more example? 2 times 5 is 10, and 5 times 2 is 10. I can trade the order, flip the numbers, and my product is still the same. Okay? Well, what do we do with this? How does that actually help us? What I'm going to do now is rewrite the previous problem and show you how the commutative property can help us. 7 over 12 times 4 over 35. I'm going to rewrite this where the numbers are multiplied in the numerator and the denominator. And look at this. If I apply the commutative property to the numerator, that says that I can trade two numbers that are being multiplied and I get the same answer. So let's trade those and write 4 times 7 over 12 times 35. The commutative property says that I can flip two numbers that are multiplied and I get the same answer. This one has a numerator of 28, this one has a numerator of 28, and the denominator is the same. Okay? But let's look at what that just did. Now I have this fraction multiplied by this fraction. Isn't 4 over 12 one of the fractions that we reduced on the previous screen? Didn't we take 4 over 12 and divide 4 out of the top and bottom and get 1 over 3? We did. That was this diagonal right here. And 7 over 35 was the other diagonal that we wrote out like this, and we divided out 7 from the numerator and denominator and got 1 over 5. So the commutative property allows us to flip the numbers. The value of the fraction is still the same, but now I can pull out two separate fractions that are each easy to reduce and simplify. So the commutative property allows us to cancel or simplify diagonally the same way that you're used to simplifying vertically. That is why this works. Now, let's try another example. And we know that this method works for simple fractions, proper fractions. What about improper fractions? Does this work if I take 14 divided by 3 and multiply it by 9/7? These are both improper fractions because the numerators are bigger than the denominators. Heavens, see if we can make this look a little bit more like a 9. Can I cancel vertically here? No. How about here? Nope. There's no common factors if I look up and down. But if I look diagonal, look at this. I get 9/3, and I can reduce that by taking 3 out of the numerator and denominator, and I get 3/1. Okay? So let's do that. If I divide 3 out of each of these numbers, I get 3 and I get 1. How about the other diagonal? Yeah, I can write 14, because it's in the numerator, over 7 is in the denominator. And if I divide 7 out of the numerator and denominator, I'm going to get 14 divided by 7 is 2, and 7 divided by 7 is 1. So let's go ahead and cancel 7 out of each of these. And I get 1 and 2. Now we're going to rewrite the fraction with the numbers that we have. I had 14/3, and now I have 2/1. 2/1 times, I had 9/7, now I have 3/1. Let's go ahead and write that out. Using our rules of multiplying, straight across the top, straight across the bottom, and 6/1 is just plain old 6. And you could go back and take the original problem if you wanted to, and either check it in a calculator or multiply out the big numbers and see if you can find the factors that reduce, and you'll get back to this number. Let's try one more example where we have mixed numbers. 2 5/8 times 4 4/7. Now, to do this problem, what we're going to do first is we're going to convert these mixed numbers into improper fractions. And if you want a refresher on how to do that, go ahead and click this link. There's a video that will show you how. So 2 times 8 is 16, and 5 is 21/8, times 4 times 7 is 28, plus 4 is 32/7. Look at this. I don't have common factors in this fraction or in this fraction. But if you look diagonally, I do have things I can cancel. 32 and 8 both have factors of 8. Let's divide 8 out of each of them. 8 divided by 8 is 1, and 32 divided by 8 is 4. 21 and 7 have common factors of 7. 7 divided by 7 is 1, and 21 divided by 7 is 3. Now I'm going to rewrite the new fractions that I have. 3/1 times 4/1. And the answer to this problem is just 12. So today we saw how we can do some of the reduction of fractions early by canceling diagonally instead of waiting till the end. Go ahead and hit subscribe. Hope you enjoyed the video. Go ahead and leave me any comments, and we'll see you next time.